Today's presentation is how to use Active Directory authentication over SMB to connect directly to an Azure File Share. There's a couple prerequisites we need to get out of the way first. Prerequisite number one is that we need access to an updated Windows 10 or Windows 2016 machine running the appropriate versions of PowerShell in the .NET framework. I'll show you how to check for that here. Grabbing the PowerShell version is pretty straightforward using the get-host command. Getting the .NET version that's installed is a little less straightforward, but at the end of the day, 461808 and above return true, then you're good to go here. Because we'll be utilizing the new Azure PowerShell modules, we'll want to make sure that the older Azure RM modules have been properly uninstalled before beginning so that we can make sure that there's no conflicts along the way. Azure provides a way to connect your Azure storage with your local network using a private endpoint. If you're planning on utilizing a private endpoint, then you're going to need to make sure your VPN or ExpressRoute connection to Azure is properly configured prior to beginning this process. Because SMB uses port 445 to connect to the Azure File Services, you'll want to make sure that your firewalls are properly configured. Additionally, if you're looking to connect over the internet to your Azure File Share, you'll want to make sure that your ISP isn't blocking this port specifically, which is often the case. It's worth mentioning that SMB 3.0 is considered internet safe and is properly encrypted. The final item to have in place prior to beginning is to make sure that you've properly configured AD Connect in your environment to synchronize your on-prem users with your Azure AD users. Rights assigned to your Azure File Share will be assigned directly to your Azure AD user, and the SID applied from the on-premises user account will be applied appropriately to the Azure AD account to maintain appropriate file permissions access. Some additional notes to consider. This configuration is supported by Azure File Shares managed by Azure FileSync. It does use Kerberos authentication and supports a single sign-on experience. However, it's only supported on clients newer than Windows 7 or Windows Server 2008 R2. Currently, it's only supported against the Active Directory for us that the storage account is currently registered against, and does not support direct authentication from computer accounts. So only user accounts currently will be able to access the shares we create in Azure. If you're currently applying a password policy specifically to your computer OUs, which are requiring password expiration, then you'll probably want to make sure to disable this policy for the OU where we're placing the computer account associated with this process. Please keep in mind that generally computer accounts request their own password changes, and password policies are not applied for computer accounts on OUs by default. You would have had to have created a specific policy for this process. Checking for the remote server administration tools on Windows 10 is pretty easy as well. You just open up the features, go to optional features. Once there, you click add a feature, scroll down to the RSAT, Active Directory Domain Services, and Lightweight Directory Services. Select that and just install it. It will take a little bit of time, but once it's in place, your PowerShell console will be prepared to access your environment appropriately. So the next step in our journey to complete the prerequisites is to install the appropriate modules for PowerShell. These include the Azure Active Directory modules, and then 3 modules specific to Azure itself, which is the Accounts module, the Network module, and the Storage module. You can, of course, install the entire suite of modules, but for this instance, I only wanted to install specifically what was necessary to complete the task. Once this completes, your PowerShell should be in a position to execute all the commands we need. and that's it. So the first step in the process is going to be creating a storage account for your Azure tenant, and that's done via the Azure portal. There's quite a few reasons to create a storage account, and one of them is Azure File. Attaching it to your appropriate subscription, resource group, providing an appropriate account, that's all pretty standard stuff here. A few things worth noting is that the ability to enable large files or replication depend on the settings you select here. So in this instance, we have quite a few options available if we remain on the standard performance tier. However, once we move to geo-redundant storage on that standard tier, we lose the ability to utilize large file shares, which are file shares greater than 5 terabytes. The maximum, I believe, in this instance is 100 terabytes. So if we want that feature, we need to make sure to select locally redundant storage only. This isn't really necessary or specific to Azure File or this demo in particular, but it does kind of help you make a decision. Again, if you select premium storage, you do not have the option of using large file shares. For this example, though, I will be using premium storage. Premium storage can only be used with local redundancy, but it does provide for the performance characteristics. So if you're looking for extra IOPS, then choose the premium disk on local redundancy and you'll be fine. Next, we'll be focusing on whether or not we want to use a public endpoint or a private endpoint. We'll be going over both, so for now I'm going to select the public endpoint. Another option to consider when you're dealing specifically with file storage is the ability for the soft delete, which may prevent accidental deletions in the instance that you don't have snapshots enabled or you need something between snapshots recovered. For the TLS version, we're going to go ahead and select the 1.2 version. Unless you have any specific reasons not to, it's definitely the more secure option and the correct choice here. Verifying the settings are correct, we'll go ahead and create that storage account. And the deployment process doesn't take too long, but we'll wait here for it to complete. Now that the deployment has succeeded, we'll go ahead and go to our new storage account. And because we selected a file specific storage account, the only option available to us in this instance is a file share, which we do want to create. Pretty simply, we'll just give it a name and the required capacity that we need. In our instance, we'll just stick with 1 terabyte. And we'll go ahead and create the share. It's a pretty straightforward and quick process. An important step in the process is to properly associate the storage account we just created with an on-premises account in Active Directory. In this instance, we're going to utilize a computer account. In order to do this, we need to import a few modules for Azure AD and some for Azure, and then connect to our Azure account. Connecting to our Azure account is going to let us to run a couple PowerShell commands which create and extract a Kerberos key, which allows us to properly associate the two accounts. So here, we're going to properly create our Kerberos key on the Azure storage account. You can see Kerb1 has been created. Next, we need to properly extract the key from the storage account so that we can use it during the creation of the computer account. So we'll copy this information and then we'll insert it into a secure string variable. Doing so will allow us to utilize this variable during the creation of the computer account in our on-premises environment. Here, we're creating the new computer account in our environment using the name of the storage account. You can also see our variable for the password is stored, which is the Kerberos key of the storage account. The most important part of this, well, one of the most important parts of this process is to make sure to provide the appropriate service principal name, which we'll check following the creation of the computer account. It may take some replication and time for this account to get created, but eventually it will show up. Once it does, make sure to verify that you do have the appropriate service account name as an attribute in Active Directory. Here you can see we do. Next is a pretty important part of the process. It's where we enable the ADDS feature against our storage account. In order to do so, we need to gather some information first. The name of our forest, the domain SID, the domain GUID we're attaching it to, and the SID of the computer account we previously created. Using that information, we can add it to the Azure storage account using the following PowerShell command. The most important part of this PowerShell command is the enable Active Directory domain services for file switch being set to true. Once we execute this command, it should properly be associated with our on-prem environment and enabled for ADDS file access using Kerberos permissions. Once we've properly enabled our Azure storage account for use with ADDS, the next thing we want to do is head over to GitHub and download a script created by Microsoft that will allow us to check whether or not we've properly implemented the configuration. Once the script is downloaded and extracted to our local environment, we can properly import the module. As a part of importing this module, it's going to install the PowerShell get module as well. This will require that we restart PowerShell prior to continuing. Additionally, you may see some null array errors pop up. I've found that these don't get in the way of the process whatsoever, but it's worth mentioning. Okay, so we're going to go ahead and restart PowerShell. And once we do so, we'll need to reconnect to the Azure account. Once we've connected to our Azure account, we're going to want to import the Azure Resources module. This module is used by the recently downloaded Microsoft module, and it'll need to be there in order for it to properly complete. Once installed, we can properly execute the debug -az storage account auth command against our storage account, and it'll run through a series of checks to make sure that our environment is good to go. It'll make sure the appropriate ports are open, SIDs have been assigned, and Kerberos passwords have been attached to the computer account properly. Looks like our environment is good to go. The next step is to properly assign permissions to the newly created share. This is where the synchronization process between your on-prem environment and your Azure Active Directory environment come into play. Using the Azure portal to connect to the file share directly, you'll go to Access Controls. Adding a role assignment, you'll first select the appropriate role. In this instance, it's the storage file data SMB shared elevated contributor role, which provides read, write, delete, and modify access. Of course, if you'd like to provide different access, you may do so. Next, select the appropriately synchronized user account and click Save. Now you've assigned read, write, delete, and modify permissions to the appropriate account. Now it's time to test whether or not these account permissions took place appropriately. Authenticating to a Windows machine joined to your domain that has access to this share, you'll connect to the namespace provided by Azure, which in this instance is going to be the storage account name .file.core.windows.net / the share name you created. This will connect to the publicly facing IP address of this storage account and file share. Because the storage account is represented as a computer account in your local Active Directory, your Kerberos permissions to this object should pass through seamlessly to the Azure AD storage account. It should seamlessly provide you access to create files and folders in this new environment. As you can see, we're able to properly connect to the share and create files and folders as necessary. Most organizations already have a physical connection to Azure, whether that be via VPN or ExpressRoute. As a result, many prefer to utilize this link to connect to their Azure File Share. Looking at the storage account firewall, you can see that this particular storage account is still accessible from the internet. Having run the Active Directory enable commands against this storage account previously, you can see that we're now configured for use on this storage account. As a result, you can no longer activate Azure Active Directory domain services against it. To connect across a private connection, you'll need to enable or create a private endpoint. This is pretty straightforward and creates an IP address that's associated with your Azure File Share. You'll need to select the appropriate resource type, which in this instance is Microsoft storage accounts, with the resource being the storage account that we previously created. The sub-resource will always be file for Azure File Resources. The next step is appropriately attaching this private endpoint to the appropriate VNet in Azure. In our instance, we do not want to select our VPN, but we want to select the VNet associated with our internal network. One thing of note is the creation of a private DNS zone. This will allow us to add this DNS zone to our internal DNS and ping the resource in Azure directly using the internal IP address instead of the publicly facing external address. And we'll talk more about that later when we configure that. So from here, review the settings and then create. Upon the completion of the private endpoint, you should be able to access this resource, and as a result, obtain the IP associated with it. This is good information because we can use this later to verify connectivity to this resource. So first step is to verify that we're pointing to the public endpoint still, which we are, as you can see here. Next, we want to connect to the actual file share. And we can see that the directories exist and that we can create new folders and files as we see fit. Additionally, we should be able to properly edit the NTFS security permissions of each file and folder. Here you see that I can apply full permissions to a local Active Directory user. Additionally, the same as expected can occur against a file as well. Selecting an on-prem user, in this instance I'm just going to choose everyone, we can provide whatever permissions we deem appropriate. The next step in the process is to verify that we can still access the environment from our private endpoint. So what I'll do is I'll edit the host file here to make sure that we're pointing now to the file share through the internal connection. We are properly resolving the storage account using the private endpoint, so connecting to that same share, you'll notice that we still have access and we should be able to still access the files as expected. The next thing that we're going to do is to make sure that our firewall has been edited on our storage accounts so that only selected networks can access this storage account. This should prevent the public endpoint from providing access to our storage account. Verifying that our machine still resolves the external IP address of the storage account, as you see here, we want to make sure that the effects of enabling the firewall for this public endpoint work. As you see here, attempting to access the share via this external IP provides us with an access is denied message. When we utilize the Windows host file to change the resolution of this address to the private endpoint's IP, we can attempt to ping that to verify that it is in fact returning that the appropriate IP, and then attempt to access that share directly using the DNS name. As you can see, access to this share is now available to us as we expected, and we can even edit the NTFS permissions. Up until now, we've been relying on host file changes to modify the resolution of the public and private endpoint IP. But using Azure's private link functionality created earlier, we can modify resolution on our internal network. So you can see the external IP here. And then in our internal DNS, we can add a standard Active Directory aware zone. We can replicate that to all the domain controllers and provide the private link name given to us by Azure earlier and continue through the configuration. Once the zone's created, we can create a new A record specifically for our Cannellini Lab Files storage account. Giving it the internal IP address of the private endpoint, we can add that host. Now that the A record exists, we can run another NSLOOKUP against the same name, and we'll see it's resolving now to the internal IP. No more host changes for us. Up until now, we've been using a relatively unwieldy namespace, Cannellini Lab Files .file.core.windows.net. In this instance, with the assistance of DFS namespaces, we'll go ahead and add a namespace, a domain-based namespace to our environment so that users can access our share using something a lot simpler. In this instance, they'll be accessing it using whack-cannellini.us whack public. We'll go ahead and give all users read and write permissions to this share. However, you can configure your domain-based namespace however you'd like. After the namespace creation completes, we'll go ahead and add a second namespace server for redundancy. Once this process completes, the next step is to add the actual namespace folder and attach that folder to our Azure storage account file share. That's pretty straightforward. We just add a new folder, give it a name. In this instance, we'll just call it home, and then point it to the actual shared folder. We could have called it Cannellini Share Files. We could call it whatever we want. In this instance, it's going to be our home drive, so we call it home. Now, we should be able to ping it directly. It should resolve the appropriate cannellini.us domain name, and then we should be able to directly access this environment via our file share. As you can see, the home folder is available to us, and when we open it, our files are there as expected. None of that messy file core Windows net stuff anymore. So there you have it. We've properly configured Active Directory on-premises authentication against an SMB share stored in Azure. We've limited access to that share from our private network and have verified that all NTFS permissions work as expected. And finally, we've created a mechanism where we can connect directly to this resource using a friendly name. If you have any questions, please feel free to reach out to us anytime. Thanks.